In this video, I will be creating a step-by-step guide on how to use CNC-RP. So the first step is to open Mastercam 2019 as an administrator and accept any changes to your device. Once Mastercam is open, navigate to your CNC-RP toolbar and select the New Project button. This will prompt you to choose a 3D model for the part you are trying to make NC code for. Before that, there are a few caveats with file choice and how it affects CNC-RP. Mastercam and CNC-RP can open all files available here. They can also open STL files. But I would suggest only using step files and IGS files. STLs, as I said before, can be used but result in slightly longer load times. More importantly, Mastercam tends to change the unit type when opening an STL file, causing many models to go from inches to millimeters or vice versa. This causes a lot of problems when importing our units into our file and can tend to mess up our tolerances. This can be bypassed within Mastercam by scaling or changing to the correct unit, but you will lose a level of exactness because of this. So I would suggest just using either an IGS or step file. Once you have considered your model, you are ready to select your part. Click the part you want to select. In my case, I will be creating this bracket, and click Open. Once the part loads into Mastercam, it's important that the part is centered on the origin. If for any chance you move the part after opening it, or that the part just doesn't center on the origin upon opening, it's important to move that all to the origin, otherwise CNC-RP will generate the code incorrectly. To do this, I would just suggest using the Transform tab and using the Move to Origin button along with the Scale or Stretch depending on what's needed. Now that we know our part's in the correct place and is centered on the origin, we can now click the Execute All Process Planning button. This button will lead you through each step of the program automatically. If at any point during these steps you close out of one of the windows, you will have to manually click the rest of the buttons to get back through the steps and finish the part. So it is best just to click the Execute All Process Planning and then just follow along step by step as it opens for you. Now that we've clicked the Execute All Process Steps button, the Analyze Setup Axis window will open. In this window, you can choose the axis that your part will be centered on. This axis is very important and impacts the amount of the part that can be reached, the stock radius and length of the part, and which surfaces of the part the supports will be added to. During this step, it's important to think about our support locations for our part. As you can see here, your part will be shown within the stock material, with its radius being in red. And this red bar shows where your supports will land. So for instance, if I was using this Z-axis, my supports would land on this side of the stock material and this far side of the stock material. For the Y-axis, it'd be this front face and the back face, etc. This is an important thing to keep in mind. If you have specific features of your part you need to keep clean or make sure you get the best machining out of. Upon opening the window, you will be left with three major axis options: your X-axis, your Y-axis, and your Z-axis. Each of these axes will tell you the visibility of the part and the stock size for that axis. If neither of the three large axes work for you, you can also choose a custom orientation for your part. To do this, click the Customize button, which will open a new window, and adjust to your specific rotation you would like. Once you've adjusted to this rotation, you can click Test, and you'll be able to see the visibility and stock size of your part at that specific axis. A word of warning: when you machine off of the normal degree axes, for instance, like machining away from 0, 45, 90 degrees, your part geometry can become less precise, and for many parts, it will not work as well to machine at these weird degree angles, like 160 and 153. So most of the time, you're going to want to stay on your more fixed angles, your 0, your 45, just to help it make it easier and faster for your part to be created. If you have found your customized angle that you would like, and the test looks good, Then just click the checkmark button and it will fill in this screen here. You will know you've selected this orientation if the little bubble is completely filled in. If you are still looking for a different orientation, you can also use our search feature. So in this search feature, you can choose to search at every angle for each axis by a certain increment. So in our case, let's do it by 25-degree increments. So if I enter 25 here, that means for every 25 degrees, CNC-RP will cut the part and run the calculations for visibility and minimum stock size. So to do this, I will click search. This process can take a very long time. If your angle increment is very small, I would suggest keeping the increment above 10 to avoid really slowing down your computer. As you get to around 5, it can take upwards of 20 minutes to get through every single option. And most of the time, those options won't necessarily be that much better than one that could be found faster and easier. But as you can see, it's now looked through every 25-degree angle, and it's found one that has the minimum diameter of 1.95 and one that also has the maximum visibility. For this part, it's pretty simple. So our visibility and stock size match just for one of the major axes, which is what's going to happen most of the time for your part. But if you have a more complicated part, this can be a good way of finding either your minimum diameter or maximum visibility. Once you have searched through all your possible axes and have determined the one you would like to select, make sure that the button is fully highlighted or fully colored in, and then hit the OK button. The next step in CNC-RP is to add our sacrificial supports. So once we have continued off of the setup axis screen, we'll be met with the support placement window. In this window, you will need to select your material you are using and the critical tolerance you would like your part to have. The smallest tolerance CNC-RP can do is 2 thou, and this is what I would suggest selecting for most of your parts. So if you are looking for smaller supports or less supports, you're probably going to have to sacrifice with the larger tolerance. But I would suggest always choosing the smallest tolerance because you can edit your support specifically after this screen. So in my case, I'm going to choose aluminum and I'm going to choose 2 thou critical tolerance, and I'm going to click the green check mark to go on again. Now we are seeing the full CNC-RP supports placement window. What you currently see is where the supports are generated by CNC-RP using your material and critical tolerance choices from before. CNC-RP will always try to generate at least 4 supports on your part, but may also create 2 or 3 depending on the part's geometry. This window also allows you to change the size, number, and position of each support. The generated supports are built in with a pretty lenient safety factor, so you can remove the supports if you choose to do so. Do this with caution though, as the code generated may not meet your tolerances that you set before, or in the worst case scenario, the part could break off of the supports during machining. So just make sure that if you make any of these changes, that you know your part is still going to be able to handle the load. To change the supports, you must first click the Unlock Manual Support Placement button. If this box is checked, you are good to move your supports. Once you choose a specific support to move, so in this case, I'm going to move this support, you can either go over to this right side screen and double click on the support until it turns yellow, or you can click on it directly in this window. Once your support is yellow, it means you're selected and it's ready to move. So to move your support, you can either click and drag on this right side window. So you can click and drag to any location on this plane to place your support. You can also directly input specific coordinate values if you wish to do so. To do that, just change your coordinate values up here and click enter, and it'll move to that exact location. As well as changing the position, you can change the diameter of your support to either make it bigger or smaller. To change the diameter, you can do it manually the same way as the coordinates, and then you can click enter, or you can double click on the very edge of your support. This will turn it and outline it in blue, and then you can once again click and drag to change its size. It's important to note that if your support is selected, it will always move. And to unselect your support, you have to double click in open space. You can also add or remove a support using your left click. So to do so, left click on any open space, and you can see here, you can use make permanent. This just makes it so that your support can't move, or make temporary, makes it so your support can move. You can also add new. This will add a completely new floating support that you can choose to move anywhere within your part. To delete a support, just left click on it and click delete, and your support will be removed. You can double click on any space here and drag to see multiple angles of the part if you wish also. Before we move on, I want to go over some important notes on supports that I have learned while using CNC-RP. First off, the side of the part the support is attached to is determined completely by your axis selection step. So it's important to choose your axis based on where you want your supports to go, as well as your visibility and your stock diameter. I personally like looking for axes that allow me to place my supports along flat sides or features that I don't mind messing up. I also look for through holes in the part, such as our through hole in this bracket here, and make sure that my supports are not on the same face as that hole, otherwise that through hole will not be able to be machined. If you have a necessary feature being blocked by a support, CNC-RP will also not be able to create it very well, and that support most likely will get in the way of our end mill. It's important to try and get those supports in the least important areas of our part. You will also have to remove the supports after machining, and this could, depending on your method, result in a lot higher tolerance error level and affect the feature of your part. For that reason, I always choose the least important features to attach my supports to. That way, even if I slightly mess up taking them off, the part's still pretty good. This is also something I like to think about when I'm designing a part specifically for CNC-RP. I will try and design models with the supports in mind. So for instance, I designed a model where most of my features were pretty important and I didn't have a good access to have our supports coming off of to get to all my features. So I intentionally designed extra material on my part for the support to attach to that I could then cut off later, saving a lot of hassle and making sure the part has really good dimensions. Once you're satisfied with your support locations, click the green check mark and you will proceed to the next window. Now that we have finished selecting our supports, it is now time to select our machining angles, or more specifically, our finishing angles. This window allows you to select your preferred finishing angles for your part. To input an angle, type any angle into this box. So if you would want an angle at 45 degrees, type in 45 and click the Add Angle button. This will then tell the program that you want to machine at 45 degrees, and the program will build that into the toolpaths. I have found that by choosing angles that are normal to the surface of important features, that those surfaces tend to have better finishes and better tolerances after machining. You may also want to specify a specific angle if there's a through hole. So in our case, this through hole, if I choose to machine from this face's angle, like straight on to this face and its back face, my end mill would never be able to reach this through hole. So when thinking about your machining angles, you need to make sure that your angle can reach all features of your part. So in this case, I have to machine normal to this surface so that I can get into those through holes. You can also click the 0, 90, 180, 270 if you would just like those 4 angles to be used. If you'd like to remove any of the angles that are already in the box, just select your angle by clicking on it and then remove selected. You can also clear all using the clear all button. If you leave all your angles box blank, the program will automatically generate for you the angles it thinks are best. So once you have chosen your angles for your finishing tool, click the green arrow. Now you should see a new window appear, and your user selection should show the angles you had selected on the previous screen, or it should show the automatically generated angles by CNC-RP. CNC-RP will also add automatically generated angles onto your chosen angles if certain features aren't able to be machined from your specified angle. The final angles used by CNC-RP will be the angles featured in your user selection box. So if in this screen, say you've decided I don't want to machine at the angle 270 degrees. You can move it using this top button that'll move it to the left. You can also use the middle button to move any of the angles over here back into our user selection. And you can also use this bottom button if you would like both to appear exactly as each other. Once you have finished your angles and are ready to go, click the green button once again. This screen will then pop up showing you your roughing and hogging angles. These angles are totally dependent on your finishing angles. So by changing your finishing angles, your roughing and hogging angles will also slightly adjust. These angles are just determined by CNC-RP to be the fastest way to get the parts down into shape. Once you have confirmed that these are your angles that you want to machine at, click the green checkmark. The next window is the machining and material selection screen. Here you can select the machine, material, and tool library you would like to use for CNC-RPs. CNC-RP will come installed with a few default tool libraries. The only accurate one will be your aluminum tools, and the other libraries, such as your ductile iron, gray iron, and steel, will all just be copies of your aluminum tooling. So if you are going to run any other material other than aluminum, make sure your feeds and speeds are correct. If you want to know how to edit your tool library, material library, or machine library, you can check out that video. In my case, I am using the VF2 as my machine. I'm going to be machining out of aluminum, and I'm going to be using my aluminum tool library. Here, I can also select my stock size. CNC-RP will not allow you to select a stock size that the part cannot fit in, but you can increase the stock size if so be it. That'll just increase your hogging time and the amount of material taking off. Your part will still end up the exact same. It may also slightly adjust the tooling choices depending on the diameter of that stock. In most cases, I just choose the smallest option that I have available for that part. Lastly, on this window, you can select the finishing strategy for your part down here. Flat mill finishing is good for highly prismatic shapes, where ball finishes are best for a really nice surface finish and are willing to put in the extra time to get that finish. I would suggest using the ball mill finish for almost every part you do, but if you really don't care about the look or don't have any curves in a part, flat milling can be faster. Once you have selected all your machine material and tool library and you're confident in your choices, then click the green arrow. For each process, CNC-RP determines a minimum tool length that the tools need to reach in order to make the features of the part. It is very important that the designated tools can reach this length, otherwise the program will most certainly crash during machining. There are some safety measures in place, such as a rule that forces each progressive tool by depth to be greater than or equal to the previous tool's diameter. This stops the end mills from colliding with existing material that hasn't been cut away yet. Without this rule, for example, a half-inch tool could be used to machine a rectangular pocket from 0 to 0.75 inches deep, leaving a large radii in the corners. Then, when our quarter-inch tool attempts to cut from that 0.75 inches deep and beyond, it will crash into the remaining material left by that half-inch tool. You can see that here, as if I select a 3/8 tool for my semi-finishing tool, I can no longer use quarter-inch tooling for the rest of the processes in order to avoid a crash. If you reselect your quarter-inch tool, the options become available once again. Though keep in mind that after changing something, some will not reset to their factory defaults, so you need to make sure to reselect all the factory defaults if that's what you want. If you are unhappy with any of CNC-RP's choices, you can just simply select the checkbox next to the tool you would like to use. Keep in mind that if the tool is too big, it will not be able to reach certain features. For instance, if you have a through hole that's a quarter-inch in diameter, and you decide to select a 3/8 inch tool for your finishing tool, that hole will never be made. Lastly, in this screen, it is very important to make sure that each tool you select reaches the desired depth. For instance, any tool in this column must reach the length of 0.75 inches. If it does not, the tool will most likely crash. Each tool in this column must be able to reach up to 1.75 inches. you can also see the max length a tool will ever need to be for your part. So for instance, in our roughing stage, we will never need the tool longer than 1.55 inches. So it's important to check your length values with these associated values to make sure your tool is always longer. I'm going to reset all of these back to their default, and then I'm going to click the green check mark to move to the next window. The next window to pop up is your CNC-RP generation. All this is saying is it's going to ask you what parts of the code would you like to generate, either all the steps, which for any part you want to make is normally what you're going to do, but you could also just select hogging, roughing, finishing by just clicking and selecting. This page will also show you your required stock dimensions. I would write these down before moving on to your next page so that while the code is generating, you can go and acquire the stock material you need. Once you have recorded these values, click the green check mark. Now CNC-RP will start generating the code. At this point, our job is done and we just need to let it get through its generation. This can take anywhere from 5 minutes to up to 30 minutes depending on the complexity and size of your part. After code generation is finished, a message will pop up saying the NC code is complete. You may also receive another system messages, such as multiple tools using the same tool number. If you see this error, just click yes and the code will slightly change to avoid the problem and become more efficient. As you can see, my code is just finishing up, as it is creating the post-processing files necessary for our setup sheet. Now our code is completely finished. You will receive a CNC-RP message just saying that your NC code is complete. Just click OK. Now it's important that after you finish running code to test its integrity and verify that your part is going to look and come out the way you expect it to. This can be done pretty easily using Mastercam's Verify Simulation tool. To do this, first move over to this green play button and select all of the operations. Then move to this check mark and the Verify Selected Options button and click that. This will then start bringing up the simulation screen. I normally run the screen at max speed, but if you want a more accurate model, run the verification at a slower speed. After the simulation is done, you will see what the part should look like upon completion. If you're unhappy with the way the part turned out, try going back into our earlier steps and slightly adjusting them to get the parameters you want. In the verification screen, you can also see any collisions the simulation has found. A common error that can occur is called the overall flute length error. This error is caused by the fact that CNC-RP allows tools to reach farther into the pocket than its cutting length. Granted, the tool all have shank diameters equal to or less than the cutting diameter, so there can only really be minor rubbing, not actual collision. Most of the tools in CNC-RP's library are neck style tools with a reduced shank diameter anyway, so this rubbing effect is avoided in reality. But you will still receive this error. Most of the time, it can just be overlooked. Once you have finished verifying your NC code, you can exit the simulation. Now navigate to your computer's files and look into your CNC-RP folder. In this case, you can get CNC-RP folder. In this case, you can get to it by first finding your Mastercam 2019 folder, getting to the RP folder, and then going into the customer folder. I will pin this customer folder as this is the folder you will be going into every time you make a new part. So it is pretty helpful to have it pinned. In this folder, you will see the generated NC code for your part, as well as a PDF setup sheet for your CNC machine. It is very important to save a copy of both of these outside of our CNC-RP folder, as every time a new part is ran or created, this folder is wiped clean and the new part's code is put into the folder. After you have saved your setup sheet and NC code, everything is ready to go and you can start creating your part. You can refer to the setting up your CNC machine video for a direct tutorial on how to do that.